we are going to be learning how to solve roots in factored form, right? So this is Q2, and let's go ahead and do something like y is equal to, let's say, x plus 2, and we'll do x minus 3, right? So if we were to graph this, right, and so on the one hand, we can kind of solve this very nicely because, well, if it's x plus 2, does that move to the left or does that move to the right? Well, remember, it's always the opposite, so it's going to move to the left, so it'll be negative 2. And so this is x minus 3, well, that's going to move to the right 3. Okay, so what that means is, this tells us that factor form tells us the location of our roots right there. So we know that my roots have to be x is equal to negative 2 and x is equal to positive 3, right? Because we see them right there. Our graph would look probably something like this right here, right? It's up, it's U-shaped like that, and it's not upside down, right? Because we don't have any negative out here. So how do we go about actually solving it, right? So that's how we could see it on the graph, and we want to be able to learn how to actually solve it. Well, what's our y value, right? Think about it. What is our y value here on the x-axis, right? Well, we're just moving either to the left or we're moving to the right, but we're not moving up or down at all. So our y value is 0. So every time we want to solve for our roots, we have to set the y value equal to 0. So we do that. We're going to get 0 equals x plus 2, and then we're going to get x plus, x minus 3. Great. Now that we have that, we can just solve it. Well, one way we solve that is we just break it up into two equations. We're going to get 0 equals x plus 2 and 0 equals x minus 3. Well, what do we do to get rid of the plus 2? We just subtract 2 to both sides. Over here, we're going to add 3 to both sides. And we get x is equal to 3, which was our rule. We kind of already showed that, and x is equal to negative 2. All right. So there it is. We got our roots from being in factored form. But let's go ahead and look at an example. Let's say y is equal to 2, 6x plus 4, and then we're going to get 3x, negative 3x plus 2. Well, how do we find the roots of an equation that looks a lot more challenging, right? It's not like this equation here. That was really easy, right? X plus 2, you move to the left by 2. X minus 3, you move to the right by 3, right? Now we kind of have something that's a little bit more complicated. So now we can actually just proceed to solve this how we did before, right? Our roots will always occur, according to our graph we have here. Our roots will always happen when y is 0. So we're going to set this equation equal to 0. We're going to get 0 equals 2, 6x plus 4. And negative 3x plus 2, right? Now we have this. Well, what do we do? This should be a plus sign. It looks really terrible. Okay. Now what do we do, right? How does this 2 affect things? Well, let's just divide by 2 and get rid of it. 2 divided by 2 is 1, and 0 divided by 2 is just 0, right? So that dilation doesn't affect our equation at all. And we're going to get 6x plus 4, and then we're going to get negative 3x plus 2. Okay. So now we go ahead and set the equations equal to 0, right? Both of them. And then we just solve. 0 equals 6x plus 4. And we get 0 equals negative 3x plus 2. Okay. Well, solving this equation here first, remember order of operations. We first need to undo any addition or subtraction. So we subtract 4 to both sides. And we're going to get negative 4 is equal to 6x. All right. And now we divide by the 6. And we're going to get x is equal to negative 4 over 6. Okay, and that's one of my roots. All right, let's go ahead and solve this problem here. Well, we subtract 2 to both sides. We're going to get negative 2 is equal to negative 3 times x. So we just divide by the negative 3 to get rid of it. And we're going to get x is equal to 2 divided by 3. Right? And these are my 2 roots. Right? So what that means is on my graph, okay, let's go ahead. This is my x, this is my y. What this means is, well, one of my roots is negative 4 divided by 6, right? This is, I think I should be 0.75 or something like that, right? So let's go ahead and just verify that. Negative 4 divided by 6. Oh yeah, negative 0.6666, right? So Here, this is negative 0.66667, or whatever you want to write. So one of my roots occurs here, and then 2 over 3 is going to be, actually it's the same thing, and this is where I got tripped up. It's going to be the exact same thing. We're going to get positive though 0.6666667, right? So 0.66667, and this is my second root, right? And my function will probably look something like that, right? Because it's going to intersect at those roots there. Awesome, perfect. All right, so I'll give you one to do on your own. We got 0 equals. You could try, 2x minus 3, and then you could try x divided by 2 plus 1, and see what you're able to do to find the roots. All right, I already set the y value equal to 0 for you, so you just need to go ahead and solve this algebraically. Cool. Hopefully that helps to solve the roots in factored form.